Morning, class. This is Mr. Walker here, coming to you with our new round of notes. We were talking about quadrilaterals last time, so this time we are going to be talking about them in the guise of the coordinate plane. So let's do a brief review of what slope and distance are with the coordinate plane, and then start talking about how these quadrilaterals are shown on there. So, first off, what is slope? Slope is usually represented by an m, which is the rate of change, which is constant in a linear equation. Now, if you remember what a linear equation was, that's when the x value is to the first power. Now, how do we find out slope? What do we use for that? Our slope is also known as m and is in its formula the change of the y values in a line over the change of the x values in the line. We also call this rise over run. Now, when we actually do this, we subtract two different y values for two different points, and we put that over the subtraction of two different x values of those same points. So, let's look at what each of these slopes will look like. When we're looking at a slope of a line, we want to talk about that change as we read that line from the left side to the right side of the coordinate plane. So, if we're dealing with a positive slope here, that means that I'm going up as I look from left to right. So think of this like you're going uphill. When you're looking at a negative slope, it's the reverse. Instead of us going up, going from left to right, we're going down, coming from left to right. Now, what if we have a slope of 0? That means that as I look at the line from left to right, the line's not going higher, it's not going lower. It's taking a constant change from the left to the right, and it doesn't really move anywhere. The distance of the x value still moves, but the y value hasn't changed at all. And then what does no slope mean? No slope is a case where we look at a line and we see that there's a change going up and down vertically, but there isn't one horizontally. And because of the nature of what this is, if this change in the x values ends up giving you 0, that makes this whole fraction undefined, aka not having a slope. So these are a couple little guides here. Make sure that you go through and have those on those papers because that will help out. Now, let's talk about slope-intercept form one more time. It's been a while since you've seen it. It's our old friend y equals mx plus b. Remember what y is? That's the y coordinate, m is the slope, x is the x coordinate, and b is the y intercept. Y equals mx plus b. That is such a fun thing to see once again. I miss algebra, don't you? Now, when we're taking a look at a equation of a line and we want to tell if it is parallel, we take a look at two non-vertical lines and we take a look at all of the things that are in these. So here's y, here's m, here's the x, here's b. If we wanted to see if these two lines, if two lines in slope-intercept form were parallel, we would look to see if and only if they have the same slopes. So if they have the same slope, the same rate of change as you look at their points, then you could say that those guys are parallel. So these guys here, we have y equals 2x plus 5 and y equals 2x minus 8. Now, they're both in the same form. Everything is set equal to the y. But when we look at this to see if they're parallel, we're specifically looking at that value of m. If the value of m is the same in both equations, that means that they are going to be parallel. Now, if you have anything that can turn into the same slope, the best way to do that is to make sure that they are in the same form. So if they're not in the same form, make sure that you manipulate your equation so that they do look like that. You want them to be y equals everything else. Y equals everything else. That's the best way that you can go through and find them. Now, what are the slopes of perpendicular lines? Perpendicular, if you remember, that's when two lines meet at a right angle. So, in the coordinate plane, two non-vertical lines are perpendicular if and only if their slopes are opposite reciprocals. Now, if you don't remember what reciprocals are, that's when we're talking about if I have a fraction, like let's say 2 over 5, the reciprocal of this is us flipping the fraction into 5 over 2. So that's just the reciprocal, but what's the opposite? We look at the sign here. This right here, this is a positive 2 over 5. The opposite reciprocal is negative 5 over 2. So I take whatever the sign is for our original slope, and then I change the sign, turn it to the opposite sign. If it was positive, turn it negative. If it's negative, turn it positive. That's the way that you go through and see this. So these two guys here, these are opposite reciprocals. So if they were inside of two different lines, that will let you know that those slopes are perpendicular to each other. Now, here's how this will look like in an equation. Y equals negative 3x plus 2 is perpendicular to y equals 1/3 x minus 7 because of these two right here. Negative 3, when you look at it as a fraction, is negative 3 over 1. And then when I put that through that opposite reciprocal mentality, that means I flip my fraction into 1/3, and then I change the sign to the opposite sign. So it was originally negative, now it's positive. That makes these guys perpendicular. Now, as we do, we always have to go through and talk about things like the distance formula. So sorry about that in advance, but it's a little review. It's okay. Now, when 2 points are on a horizontal or vertical line, you could just count how far they are. But if they're on a diagonal line, that means that we need to use our distance formula. Now, if you don't remember what this is from way back in Unit 1 of our book. Between these 2 points, x1 and y1 and x2 and y2, the distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. If this is too much for you to keep track of, remember what we've done in the past. The distance formula is really our change in x. So our change in x squared plus our change in y squared. Now, another way to think about this is the distance formula is basically the Pythagorean theorem, okay? So if you can go through and turn any 2 points into a right triangle, which you can, that means that you'll be able to go through and do the Pythagorean theorem to solve for that stuff, okay? Now, let's take a look at a couple of examples, folks, to see if some stuff is parallel, perpendicular, or how could we draw a parallel or perpendicular line. So, our first example here is asking to find the slope of each of these lines and tell us if this is parallel. Is line A parallel to line B? So, when we're looking for the slope, we have our change in our y values over our change in x. So when we look at this, here's our 2 points here. We want to go through and not only notice them, but we want to actually identify them. So this point down here, our x value is 1, 2, 3, 4 to the left, making it negative 4. Its y value is 1, 2, 3, 4. 4 below the x-axis, making it negative 4, negative 4. This point here is right on the y-axis. So that means its x value is 0. And its y value, it's 2 up over the x-axis. So that is 0, 2. And then for over here on line B, this first point, this is 2 to the right, making this a 2, a positive 2 for its x value. and it's 1, 2, 3 below the axis, so that is -3. Now over here, let's check this next one. We got 1, 2, 3, 4, 5 to the right, and 3 up. So this is 5, 3. So let's look at our slopes for these guys, okay? Our slope for line A, we look at the change in our y values. So going from here to here, am I going up or am I going down? I'm going from -4 up to +2. So that means I went up a total of 6 boxes. So the top part of our slope is 6. And then how many did we move over? How many did we move to the right? What is our run on this? We went from -4 over to 0. So that makes this a +4 again. Now, what is 6 over 4? Could we reduce this? Absolutely. We could turn this over into 3 over 2 because that's how this reduces to it. Okay? Now, that was our slope here for A. Let's take a look at our slope for B. My y value for this point is -3, and the y value for up here is +3. So I do go up again 6 times. So I went up 6. Now what about my y, sorry, not my y, my x values. My x value here is +2, and this one is +5, making this a change of 3 for my x's. Now, what is this when we go through and reduce this? You can reduce this down into 2 over 1. So is 2 over 1 the same thing as 3 over 2? Definitely not. So these guys are not parallel. So you have to first identify your points, go through that change of y, change of x, identify that. If you need to reduce it, reducing it is the best way to really compare this. And then you can tell if they're parallel or not. Okay, next thing we got us an example where we're actually going to go through and draw a line parallel to this line here, A, using point N. So let's look at line A here and see if we can figure out its slope. First off, let's take a look at how our slopes look like from our first round of notes. Our first ones that we were dealing with were looking more like this. They were going up, they were positive. But the example that we have here for now looks like this, making it a negative slope. So I know that my slope here, my slope is a negative value because I'm going down on this line. So how much am I going down? Let's identify our points. This point is 1, 2, 3 above the x-axis and straight on the y. So this is 0, 3. And this point here is 4 to the right. No, 1, 2, 3. Yep, 4 to the right. And 1 up. So how did I change for my y's? I went from 3 down to 1. So that means that I went down 2. And then how much did I change for my x's? I went from 0 to 4. So that makes it 4. Really what this is saying, if we reduce this, we have a slope of -1 over 2. So this will tell us how much we need to move here. We need to move 1 down, and then we need to move 2 right. And obviously, if you're going in the other direction, just reverse that. Instead of you going 1 down, you go 1 up, and then instead of going 2 down, 2 left. Here's what we mean. So if I go through from here to my next point to the right, I go 1 down and 2 to the right, right over here. If I wanted to go in the other direction, instead of me going 1 down, I go 1 up and 2 to the left. So right over here. That right there gives me enough information to go through and draw that line. So identify your first line and then be able to go through and make that second one. Okay, take a pause and try these next ones out, okay? All right, hopefully you're able to go through and take a pause and try some of these out. These next ones, we're trying to see if the slope of this line and this other line here, A and B, are they perpendicular to each other? That means that we have to check to see, are they the opposite reciprocals of one another? The second one that we have here, we're actually going to draw ourselves a perpendicular line. So let's remind ourselves what perpendicular lines have before we even jump into this, okay? Perpendicular lines have the opposite reciprocal slope. So when we first observe this, we want to look at one of the slopes of our lines and then see, does that slope take that opposite reciprocal on our other line? So let's observe our first one here for A. When I look at 2 points here on A, let's go through and identify these two. So this point here is 1, 2, 3. Wait, hold on, double check. 1, 2, 3, 4. So this is -4 for its x value. And then I went up 1, 2, 3, 4. So that's -4, +4. Now this point happens to be a common point for both line A and B. So let's go through and figure out what this one is. This is go to the right one and then down one. So this point here is 1, -1. So what changed from us going from up here to down here? I know that the slope here for A has a negative change in it. So that means the top part of our fraction is going to be negative. I went from +4 down to -1. So that means I had a slope of -5. And I went from -4 all the way over to +1. So that is +5. What's -5 over 5? This is just a slope of -1. Now, let's check to see if that opposite reciprocal is happening. The opposite reciprocal of -1 is +1. So does this guy have a slope of +1? Let's check. Looking at my points, if this has the opposite reciprocal, that means that from here, I'm going up 1 and over 1. Ooh, it's looking like that. Let's check again. Looking like that again. Is it working out? It might be. Now, if you don't feel comfortable eyeballing it like this, we can always look at the slope between one of the points on our line and that same point here. So let's do that. This point over here for line B is, let's go and check. 1, 2, 3, 4, 5, and this is 6 for its x value. And I went up 3. So 6, 3. Let's look at our slope here. Our slope for line B, it has us going up. We have a positive slope. So far so good. That's one of the things we want. But how much did we go up by? We went from -3 up to positive, not -3, -1 up to +3. So -1 to +3, that's a change of 4 going up. And then we went from 1 over to 6. So from 1 to 6, that's a change of 7. I swear the 6, 7 jokes just keep on coming. In this case, is this the same as this remotely? It's not even the same thing as this guy. They're not even the same numbers. So because of that, these guys actually do not have the same slope. I might have actually overcounted on this now that I look at this. Oh, this is a +1, not a -1. Gotta fix that. See, folks, it's okay to make mistakes. Change that. Put that as a 5. Diddle-a-doo. There we go. So, when you go through and look at it, you don't always want to eyeball it. Sometimes your eyes can lie to you. I started noticing, honestly, when I got past this first step, that it started not looking as even as I'd like it to. So that's why I started observing it with the actual slope in mind. So these guys are not perpendicular. All right, home stretch, folks. We got one more here, and then we got a couple down below. First off, let's look at our slope here for A, and then we're going to make a perpendicular line going through A and this point here for N. So these 2 points here, let's see how many did we go up. I know I'm going up 1, 2, 3, 4, 5, 6. So I went up 6. And how many did I go over? 1, 2, 3, 4, 5, 6. So it looks like I'm going 6 over 6. Now let's check to see if that is the actual slope using the points. Using our points here, we want to go through and check these. This is 1, 2, 3. This is -3 and -2. This one over here is +1, 2, 3 and 1, 2, 3, 4. So this is 3, 4. So what's changing? I'm going from -2 to +4. That is up 6. I'm going from -3 to +3. That's over 6. Now, 6 over 6 is our original slope. That's our original m here. When I take the opposite reciprocal, that means that it would be -6 over 6. Or, if you wanted to get real technical in it, this is +1, this is -1. Now, when we do that, we can just go through and make that line nice and easy. We just follow from M as our starting point, and then just go over 6 and up 6 in the other direction. And now we have our line. All right, last two that we got here, we got us going through and graphing this equation in the coordinate plane and putting this in slope-intercept form. So then we go through and do that, and then we are going to do some distance to round out this video, people. All right, first off, slope-intercept form, if you don't remember, is y equals mx plus b. So is this whole thing set up like this? No, everything's not set up equal to y. So let's get that guy all handled. First thing we got to do is we got to move that 2x to the other side. So I subtract the 2x. And then I got to deal with this 6. When I take that 6 and get it away from the y, that means I got to divide each of these things by 6. Now, -2 can't be divided by 6, but it can be reduced down into a fraction. 6 can be divided by 6, so that's nice and easy. This is our version of this equation in slope-intercept form. And when we do that, we can start off with here. This right here is our y-intercept. This is at 0, +1. And our slope here, -1 over 3, this is telling me I'm going down 1 and to the right 3. So let's get that done. Boom. There's our line. All right, next thing we got some distance formula going on here. So finding the distance between these two, we can go through and figure this out real quick. We got to deal with our y's first. Our y's are +4 and -3. Our x's are 9 and 2. So both of these so far, it looks like I'm going down, so I can go through and observe some things. I'm going down from 4 to 3, which is us going down by 7. And I'm going from 9 to 2, which is also going down by 7. So let's see if this works out for our distances. I got 2 minus 9 squared and -3 and -4 squared. When I go through and do this, I get 98. If you're wondering how I got 98, remember, if both of these give us 7, 7 squared is 49. 49 plus 49 gives me 98. Now, when we go through and do this, this is around 9.9 if we took the square root of that. All right, last one we got, same type of deal. So our first part is subtracting the points for each of these. It doesn't necessarily matter because remember, this is an addition problem. But our change from here to here, from 0 to 8, remember what that is. That's 8. That's easy for us to count. And for our x values, I'm going from -4 up to -3. So when I go through and do this, this gives me 8 squared and 1 squared, which is 65. And when I take that square root, this is around 8.1. I know this was a little bit of a doozy, folks, but I understand that it's been a while. All right, folks, I appreciate you watching this. See you later.